Here I'll discuss division of polynomials, remainder theorem and factor theorem. First of all, division of polynomials. Now division algorithm states that dividend equals to divisor into quotient plus remainder. Okay. If px and gx are two polynomials such that degree of px is greater than equal to degree of gx and gx does not equals to 0, then we can find polynomials qx and rx such that px equals to gx multiply qx plus rx. Here px is the dividend, gx is the divisor, qx is quotient and rx is remainder. Okay, here either remainder rx equals to 0 or degree of remainder is less than degree of divisor. Okay, before starting division process, we first write the dividend and divisor in standard form. What is the standard form? That is arranging the terms in decreasing order of their degrees. Okay, now here divide px by gx, where px is a quadratic polynomial 2x plus 3x square minus 1 and gx is a linear polynomial 2 plus x. Okay, here degree of px is greater than degree of gx. So now first of all write the dividend and divisor in standard form. Okay, so dividend is written as 3x square plus 2x minus 1, that is in order of decreasing powers of the variable, and divisor is x plus 2. Okay, now the first term of quotient. How the first term of quotient is obtained? We divide the first term of the dividend, okay, by the first term of divisor, that is we divide 3x square by x, which is equal to 3x. This is the first term of quotient. Okay, now we multiply divisor by the first term of quotient and subtract this product from the dividend, that is multiply x plus 2 by 3x. Okay, so 3x multiply x is 3x square and 3x multiplied 2 is 6x. Okay, now subtract this from the dividend. On subtracting, the signs will change, so 3x square minus 3x square is 0, it will cancel out. 2x minus 6x is minus 4x minus 1. This is the remainder here. Now it will become dividend. Okay, so the second term of quotient is obtained by dividing minus 4x, okay, by x. Okay, because minus 4x is the first term of dividend here. Now it will be equal to minus 4, which is the second term of quotient. Okay, again multiply minus 4 with x plus 2. Okay, so on multiplying minus 4 with x plus 2, the product will be minus 4x minus 8. Okay, now again subtracting this, so sign will change on subtracting. So minus 4x plus 4x cancel out, 8 minus 1 is equals to 7. Okay, so the quotient here is 3x minus 4 and the remainder is 7. Okay, now this process continues, this division process continues till the remainder becomes 0 or the degree of the new dividend is less than the degree of divisor. Here the new dividend 7, okay, has degree 0 and the degree of divisor is 1. So since the degree of this dividend is less than the divisor, so division stops here and this is our remainder. Okay, now what is remainder theorem? Then remainder theorem is let px be any polynomial of degree greater than or equal to 1 and let a be any real number. Now if px is divided by the linear polynomial x minus a, then the remainder is p of a, that is the value of polynomial px at the 0 of the polynomial x minus a. Okay, now proof of this remainder theorem is division algorithm states that px equals to x minus a, that is the divisor, multiply quotient plus remainder. Here qx is the quotient, rx is the remainder and x minus a is the divisor. Okay, so the degree of x minus a is 1, that is the degree of divisor is 1. So degree of remainder is less than degree of divisor, that is I can say that degree of remainder rx is less than 1, which will be equal to 0. So I can assume rx equals to r, a constant. Okay, so this equation will become px equals to x minus a multiply qx plus r. Okay, now put x equal to a here. So on putting x equal to a, it will become p of a and this term will become 0 because a minus a equals to 0. So p of a equals to r. Okay, so the remainder is P of A, that is the value of polynomial at x equals to A, which is the zero of the linear polynomial. Okay. Now next is find the remainder when this polynomial is divided by x minus 2. Okay. Now I have to use remainder theorem here. Let P of x equals to x raised to power 4 plus 2x cube minus 3x square plus 4x minus 5. Okay, and g of x is x minus 2. Now for finding the value of remainder when px is divided by gx, okay, it will be equal to value of px at the 0 of gx. Now how can we obtain 0 of gx? Put gx equals to 0. So on putting gx equals to 0, that is x minus 2 equals to 0, value of x is equal to 2. Okay, so remainder will be equal to value of this polynomial at x equals to 2. Okay, so 2 raised to power 4, replacing x with 2, plus 2 multiply 2 cube minus 3 2 square plus 4 into 2 minus 5. On solving this, 40 minus 17 equals to 23, which is the remainder in this case. Now you can also cross check it by actual division. Okay, what is the actual division? X minus 2, okay, is the divisor, and the dividend is x raised to power 4 plus 2x cube minus 3x square plus 4x minus 5. Okay, first term of quotient will be x raised to power 4 divided by x, that is x cube. So multiply x cube with the divisor, x raised to power 4 minus 2x cube. Then subtracting this, sign will change. So it will become 4x cube minus 3x square plus 4x minus 5. Now second term of quotient will be obtained by dividing 4x cube by x. So it will be 4x square. Okay, so multiply 4x square with x minus 2, 4x cube minus 8x square. Now on subtracting, sign will change. So remainder will be 5x square plus 4x minus 5. The next term of quotient is 5x square divided by x, that is 5x. Now 5x multiply x is 5x square and minus 5x into 2, 10x. So minus plus on changing the sign. So it will be 14x minus 5. Now next term of quotient will be obtained on dividing 14x by x, that is 14. So multiply 14 into x, minus 14 multiplied 2 is 28. Okay, on subtracting, that is changing the sign, the remainder will be 23. Okay, so I have verified by actual division also that remainder will be equal to 23 in this case. Now find the remainder when this polynomial is divided by x. Okay, let p of x equals to 2x cube plus 3x square minus 5x plus 6. Okay, in the first case, g of x equals to x. Now find 0 of this polynomial gx. So for this, put gx equals to 0. So this implies x equal to 0 is the 0 of gx. Now remainder will be equal to value of polynomial at x equal to 0. So p of 0 equals to 0 plus 0 minus 0 plus 6, that is equals to 6. This is the remainder here. Okay. Now in the second case, this polynomial is divided by 5 plus 2x. So gx is 5 plus 2x here. Okay. Now first find 0 of this polynomial gx. That is, put gx equals to 0, 5 plus 2x equals to 0. So x equals to minus 5 by 2. Okay. Now remainder will be equal to value of polynomial at minus 5 by 2, which will be equal to 2 multiply minus 5 by 2 whole cube plus 3 minus 5 by 2 whole square minus 5 multiply minus 5 by 2 plus 6. Okay, that is replacing x with minus 5 by 2 in this equation. On solving this, remainder will be equal to 6. Okay, now next is factor theorem. Okay, it is based on remainder theorem basically. If px is a polynomial of degree n greater than or equal to 1 and a is any real number, then I can say that x minus a is a factor of px if p of a equals to 0. Okay, that means p of a is equal to remainder. So if remainder equals to 0, on dividing px by x minus a, so I can say that x minus a is a factor of px, because for example, if on dividing 6 by 2 the remainder is 0, so I can say that 2 is a factor of 6. So similarly, on dividing px by x minus a, if remainder is 0, that is p of a equals to 0, so x minus a is a factor of p of x. Or vice versa, if pa equals to 0, that is value of polynomial at x equal to a is 0, then I can say that x minus a is a factor of px. Okay. Now check whether the given value x minus 3, the given polynomial, is a factor of these two polynomials or not. Okay. So first of all, put x minus 3 equals to 0. So value of x equals to 3. It is the 0 of this polynomial. Now you have to find the value of this polynomial. Let this as px and let this as rx. Okay, now you have to find value polynomial at x equals to 3. So p of 3 equals to 3 cube minus 6 multiply 3 square plus 11 multiply 3 minus 6. Okay, which will be equal to 27 minus 54 plus 33 minus 6, and the value will be 0. Also here r of 3 is 3 multiply 3 minus 9, so value is again 0. So I can say that x minus 3 is a factor of, because p of 3 is also equals to 0 and r of 3 is also equals to 0. So x minus 3 is a factor of px as well as rx. Okay. Now use factor theorem to determine whether gx is a factor of px or not. Okay. In the first question, px is given as a cubic polynomial and gx is a linear polynomial. So first of all, find 0 of this polynomial by putting g of x equals to 0. Okay. Now g of x equals to 0, this implies 3x minus 2 equals to 0. So x equals to 2 by 3. Okay. Now value of this polynomial at x equals to 2 by 3 is, replace x with 2 by 3. Okay. Plus 2 by 3 whole square minus 20 multiply 2 by 3 plus 12. Okay. So it will be equal to 8 by 9 plus 4 by 9 minus 40 by 3 plus 12. Okay. Taking 9 as LCM, 12 minus 80 plus 108 equals to 40 by 9. Okay. Now since p of 2 by 3 does not equals to 0. Okay. Since p of 2 by 3 does not equals to 0, so I can say that gx is not a factor of p of x. Okay. Then second one is again putting gx equals to 0. Okay, that is x plus 1 equals to 0. The value of x will be minus 1. Okay, now finding the value of this polynomial at x equals to minus 1. Replace x with minus 1 in this equation. Okay, on replacing x with minus 1, the value will be minus 33. Again, since p of minus 1 does not equals to 0, so I can say that gx is not a factor of px. Okay, and if the value of remainder, that is the value of polynomial at the 0 of gx becomes 0, so I can say that gx is a factor of polynomial px.